Hey everybody, your friendly math tutor here with your friendly math tutor's Desmos review for the digital SAT math section. All right, so as we know, Desmos is a big part of the SAT, and the point of this video is I'm going to work through 26 problems broken up into 8 parts, kind of the most important, I believe, techniques that you need Desmos for. So a couple things is that the each problem that we attack on the digital SAT, we should be the digital SAT is really all about decision making. We should be thinking like, what's the best approach to this problem? So every problem that I've chosen here, Desmos is applicable, and I'm using the problems to show you the techniques, but it may not be the best way to do it. So I am in no way saying that Desmos is the best way for every one of these problems. This point of this video is to show you the Desmos techniques through actual, SAT type problems. I'm going to make a future video where I talk more about that, and really all my content and everything that we do here at Your Friendly Math Tutor for the SAT is surrounded around all about decision making. But in this video, I'm just using these problems to show you how to use Desmos. It's more of a Desmos how-to. The other thing is, I broke it up into 8 parts, so kind of 8 different techniques that you can use on the digital SAT in Desmos. But there are more advanced techniques that exist. I just didn't include them in here because I don't think that they're actually necessary. If you have a really great score or you really like using Desmos and you want to use them in more advanced ways, then great. There's so much cool stuff you could do with Desmos. But this is more for like the beginner to moderate. Even you can get a super high score with what I'm showing you here. But it's not the most advanced techniques, but I don't think they're necessary. So there are some other great videos out there that go over these advanced techniques, but this is just for the typical techniques, all the things that I think are must-knows before you head into taking the actual digital SAT. All right? With that being said, let us dive in. So, part 1 here on solving equations. There's really 3 different ways that I'm going to show you to solve equations on the SAT. So, way number 1 is to just put in the equation in your first Desmos space exactly as is. And then I'm going to put this 7x plus 9 in parentheses so that when I divide, it stays in the numerator by itself and it doesn't just put the 9 in the numerator. And when you do this, what Desmos does is it solves it automatically for x, and then when you graph x equals whatever number, it graphs it as a vertical line. So when you put it into Desmos, you're going to get a vertical line or multiple if there's more than one solution. So all we have to do is kind of zoom in here, and we see that the solution is clearly at 3. So that is our answer. The downside of this method is that if this were like a decimal, we might not be able to see it because it doesn't really let you click on it. And also, if there's infinite or no solution options, it wouldn't be great there either. You'll see that problem in a couple minutes, simply because they would both show a blank Desmos screen. You wouldn't be able to differentiate between the two. All right, but for a lot of equations, just throwing it in as is and knowing that you're looking for the vertical line or lines as your solutions. All right, let's move on to problem number 2. So this is an example of one where you don't need to write the equals 0. We are just going to put in just the left side. SQRT is the shortcut to bring up the square root, plus 1, and then squared, and then I'm going to go minus 2, and then SQRT x plus 1, and minus 8. Now, this way is you're making sure it's equal to 0, which this one already is. You're just putting in the left side, so it's graphing the left side, and when it's equal to 0 is simply just the x-intercept. So if I scroll over here, and the x-intercept will highlight now, And so if it were like a decimal or something, this would be a good method. So making it equal to 0 but not writing equal to 0, we'll just graph it, look for the x-intercept, and therefore our answer is x equals 9. Okay, let us move on to the last problem in this part. And what we're going to do here is realize that they want to know how many solutions. So we definitely want to use Desmos for it. And it also, the thing is if there's no solutions or more than 2 solutions, you are going to be looking at a blank Desmos graph, and you're not going to know the difference. So the other option, the third way I'm going to show you to graph an equation, is instead of bringing all this to one side, just graph the sides separately. So 9 minus 6x is the left side, and then go to a new space and graph the right side. So negative 1/11 times 66x minus 99. Whoops. And what happens is it graphs both of them. And so you just look for the intersection points. But here, it's the same line. So this is no substitute for the concepts. We should know that the same line means an infinite number of solutions. But no solutions would be a pair of parallel lines, or just no intersection points at all. So when you do it this way, you can clearly differentiate between no solutions and infinite. And in this case, infinite is just this more than 2 option. All right, let's move on to part 2. So here in part 2, we got a couple of inequality problems. So this is a pretty typical problem. Just solving systems of inequalities in general, the way you would actually do that in school is you would graph it by hand. So this is just clearly a Desmos problem. So we're going to have y, and then the less than or equal to will be down here. We get negative x squared plus 8, and it graphs that with the shaded region being the solution region. And then I have y is greater than or equal to x plus 2. All right, this is a pretty tricky problem, actually. So basically what happens here is they do the shading. So we have the shading for the first one, and we have that was actually the second one, and the shading for the first one. We want the overlap of the shading. So this like purple and black region, this little like curved with a diagonal here, that little shape there represents our solution region. And they say A, B is a solution, so that's just x, y. What's the maximum possible value of B? Well, B is the y value. So what we're looking for is the highest y value we could have, which is actually up here at 8. It's not these. You might think it's those, but so these are kind of our boundary points. But the highest y value we can have is actually going to be 8. All right, so we're just using the Desmos graph and answering the question appropriately and realizing that B is just y. So the largest y value in our solution region is 8. All right, moving on to our other inequalities problem. So this one just says which of the following must be true. So they are just, basically, if we did this by hand, we would just be getting x by itself. But it's easier, I think, to use Desmos because of all the fractions involved. So this one I am going to put in as is. And then greater than, and then 1/2 x minus 10. And the way this works is it's, again, just like putting in an equation, it's going to graph a vertical line and then shade on one side of that. So I'm going to zoom out a bit, and I see that it is everything to the right of negative 24. And it's a dashed line, so it's not including negative 24. So everything to the right of negative 24 is simply going to be x is greater than negative 24. All right, so just like an equation, you just throw in the inequality right there, and you just look for the vertical line. Shading to the right is greater than, shading to the left is less than. If you have a dashed line, that's just greater than, and if you have a solid line, that's greater than or equal to, and likewise for less than or equal to. All right, let us move on to part 3. So part 3 is all about solving systems of equations. Now, you can just throw a system in, but on some problems, we have to do a little bit of work first. So in a problem like this, we have a group of 202 people, and we have a total of 60 tents. Some tents have 2 people and some have 4. So basically, we can say that X is the number of 2 people tents. So that's 2X, plus, and Y is the number of 4 people tents, so 4Y, and that's a total of 202 people. And then our tents are just X plus Y equals 60. So that's our system. And the thing is, we could solve this by hand, but I think it's just easiest to use Desmos. And know what we're looking for, exactly how many 2-person tents that are there. Well, the 2-person tents is X. So we're just going to graph this in Desmos, and we're going to find the intersection of the 2 lines, and the X coordinate of that is our answer. So just a quick 2X plus 4Y equals 202, and then X plus Y equals 60. And we're just going to zoom out a bit until we find the intersection. You just click on that. The intersection is 19, 41. So therefore, the X coordinate was the answer. So the answer must be 19. All right, so when you're graphing a system, just graph them separately and look for the intersection. All right. Let's keep it moving here and take a look at our next systems problem. So, again, we could solve this using just like straightforward substitution methods. But if we're going to use Desmos, I just want to go over, again, how to do that. So you just put them in separately, so it's really no different than the last problem. But there's something else I want you to look out for here. So x squared plus y equals 96. Now, what can happen is you can get more than one intersection point. But notice, let me actually go back to here. Notice that I don't want to spend a bunch of time scrolling all over the place. They told us that y has to be less than 0. So if y is less than 0, then I really want this intersection point down here because that's below the x-axis where we would have negative y values. So I'm just going to head down here, and I'm going to click, and it's going to give me the intersection. That intersection is 16, negative 160. So the value of y is equal to negative 160. All right, so just they gave me this. If they said y was greater than 0, I would have scrolled and found the other intersection point. Okay. Let us move on to the next part, part 4 on functions. So we take a look at this problem, and f is defined as some function where the a and b are constants, and g of x is f of x plus 2. All right. So the graph of f of x in the xy plane passes through these points. Which equation defines the function g? Okay. So a couple different things that we could do here in Desmos. I'm going to take you kind of through how we can do the whole problem in Desmos. So I'm going to add a table. And in that table, I am simply just going to put these 2 points. So 0 and 36, and then negative 3 and 9 over 16. And then over here, I'm going to hit that little button on the left with regression, and I'm going to change it to exponential. So what it's doing is it's giving me the equation to be y equals 36 times 4 to the x. So what I'm then going to do is I'm going to now use that to find the equation that defines g. And I'm going to do it this way. So I'm going to say f of x equals, and I'm going to make it the 36 times 4 to the x. All right, and I'm going to unclick this one. So I just want this one clicked. Actually, I'm going to end up not wanting that clicked either. And then I want g of x. I'm going to define g of x as f of x plus 2. And I'm going to unclick this. So really, all I have here is f of x plus 2. Okay, that's what I want. G of x is f of x plus 2. I'm looking at g of x. Which of the following defines g? Now I can just check my answer. So I can go g of x equals 216 times 3 to the x, and I get a different answer. So then the next answer, I'm just going to change the 216 to 324, and I get a different answer. So now I'm going to change it to 288, but I'm going to change the base to 4, and I get the wrong answer, so it should be D. I'm going to change that to 576, and you can see I get the exact same answer. I get the exact same graph. All right, so I made a table to figure out the equation quickly of the exponential. Then I made f of x equal to that, and then I made g of x, f of x plus 2, and then just typed in the answers and see which one lied on top. All right, so again, as I said in the beginning of the video, I am not saying that this is or is not the quickest way to do it. The point of this is to go through that you can do all this, okay? That all of this is possible to do in Desmos. Basically, the shift, highlighting certain graphs, using the answers, all of that can be done here to do this functions problem in Desmos. All right, so we now know that the answer is D. All right, let us keep powering through this, and we are going to take a look at the next problem. So we have a function defined here and another function defined here, and it says that the one is shifting the graph to the left by k units. What's k? So let's just throw these in here. So f of x equals x minus 3 squared, and then g of x equals x squared plus 4x plus 4. All right. So all we have to do is know which way they're talking. So we're going from f to g. So f is right here at 3 and g is right here at -2. So if you are shifting that left, you're going 5 units to get from 3 to -2. So the value of k here is simply going to just be equal to 5. We shifted 5 units to the left. So comparing shifts in graphs, if it's given in different form, then you might want to do it by kind of just looking at it. But since the second one here is given in standard form of a quadratic, I think it's a little easier to just use Desmos. Okay. And even if you disagree with that, this is just to show you how you can use Desmos if you choose to. All right, let's keep going. And we have another functions problem. Okay, so again, we are just going to type everything in. So f of x equals x squared minus 2. It's also important to note that if I was only graphing x squared minus 2, I wouldn't have to do the f of x equals. But here I do want to differentiate between them because they're different functions, so we need Desmos to realize that. Because then what I'm going to do is I'm going to graph f of g of x. And it's like the other problem. I'm going to get rid of these two. So I'm only looking at this. And then I'm going to graph these. I'm just going to put them in and see which one is the same. So 2x squared minus 5 is wrong. Then I'll do minus 11, wrong. Then minus 12x plus 7, and then I got to switch this to a 4. And again, so it looks like, oh, nope, it should be 12x. And that is the same, right? So I got my answer, so the answer should be C. All right, so a couple things that I'm doing that I did on the other one is not highlighting these. If you keep these there, then it gets kind of confusing as to which ones you're trying to match. So get rid of those, only keep the one that you're looking at, and then don't put these in all different ones, just for a couple reasons. Just keep it in the same one so you're not looking at too many graphs. And then you could just like manipulate it a little bit, like changing the 5 to an 11, and just to save as much time as possible. All right, but when we want to know which expressions are equivalent, we're just looking for where the one graph lies on top of the other. All right, let's move on to the next one, and this is our last functions problem. So this one's kind of cool because this one, you literally just type everything in as is, and this is a good example of you might not need Desmos for this, but it's just cool to see that you could use Desmos, especially if there were more like fractions or stuff like that. But again, I've got to put the f of x because the second one is calling on the original f of x, so I can't write like y equals or anything. I don't care about the graphs. I'm literally just going to do g of 3, and I'm done. My answer is 23. All right, so by typing in f of x and then g of x is based off f of x and then g of 3, Desmos will just do all of that for you. You absolutely should know how to do that, but the key is to know how to do it, and then you decide like, oh, can I just plug that in and do it quicker like myself, or is it quicker for me to just type it into Desmos? That's where the decision making comes in, and sometimes it can be subjective, and it's just kind of up to you. But you don't want to be in a situation where you like don't know how to do it one way or the other. You want to know all ways, and then you kind of get to make those decisions. Okay, so that is it for our functions. So let's move on to part 5, where we are analyzing graphs. So here, we are just going to be typing in and looking at the graph. So in this case, since I'm not using any g of x or calling on it with any other part of the problem, I can literally just put it in as without the y equals. I know it's not saving a lot of time, but you might as well save any time that you can. So I get x squared minus 2x plus 4. So I just graph it, and the smallest value of y is going to be this lowest point here. Oh, I realize now what I did wrong. So I'm glad I made that mistake because I should have put it in parentheses the way that the problem did. And I got lazy there. Okay, so I'm glad we saw that. So now we actually have the right graph here. And the minimum y value is 8. All right, so really be careful with your parentheses and whether you're like still in the exponent or out of it or not. All right. Okay, so moving on to the next analyzing graphs problem. And we've got this function, and for how many seconds does the ball stay above a height of 8 meters? So here's a cool way to do this problem. So I'm just going to put the function in, which again, I'm not evaluating the function anywhere, so I am not going to write the g of x equals. So I'm just going to put in the right side just so that it graphs it. And then what I'm going to do is I'm going to put in y equals 8. So that tells me that it's going to be at that height here at 0.763 and then again at 5.23. So therefore, what I have is that's like when it starts to go above 8 and then when it hits 8 again. So how many seconds does it stay above? I just need to subtract those values. I think it's pretty obvious that if I take 0.76 away from 5.23, the only answer that makes sense is B. But I can just, here's what I'll do. So you can just Command C this one. and then minus, and then go do it with this one. So a little copy and paste, Command C, Command V, and you get 4.47, which again, or you could have just used a calculator, but just to see, you can copy and paste within Desmos, and that works fine. All right, let's move on to the next analyzing graphs problem. All right, so here's a cool one. So there's some things you can do with circles. You should absolutely know how to rearrange this and find the center of the circle. And if you get good at that, you could probably do this in your head. But I'm going to save that for another day. I want you to know how to do circles, how to graph circles in Desmos, okay? And not really how to graph them. Obviously, Desmos is doing it for you. I mean how to interpret the graphs. So I just put it in as is, and it will sure enough be a circle. And if I want to find the center, Desmos will always highlight the highest and the lowest points, all right? So notice they have the x in common, so therefore the center of the circle has to have an x coordinate of 4. And there's only one answer that does, so I've already got the answer. If you're not, and then you either find the halfway point of the y's, or you go over here and you find like the leftmost point is 1 and the right is 7. Sorry. 1, 1, and 7, 1. So those y coordinates in common are 1. So or in this one, you might be able to just see it. I'm trying to stay away from that because, like, if it were decimals, you wouldn't be able to do that. So again, highlight the lowest and highest points. The y coordinate or the x coordinate that they share is the x coordinate of the circle of the center, and then highlight the leftmost point and the rightmost point. And the y coordinate that they share is the y coordinate of the center. Okay, so that's how you can find the center of the circle. All right, and one more circle problem is I want to find the radius. So in this one, again, you should know how to do it the other way, but with all these fractions, it's going to be a little easier to do Desmos. So you should have both of them in your toolbox as ways of finding the radius of a circle or the center of the circle like the last problem. So I'm just going to put it in as is. Plus 3 over 2y equals 157 over 4. I just want to make sure I put all that in right. 1/2, 1/2, 3/2, 1/2. Okay, I did. So I'm going to zoom out a bit. All right, just like the other one, I'm going to highlight the top and bottom points because they always allow you to do that. And now what you have is, so, based on the last problem, I know the x coordinate of the center was negative 0.5. But what I really want is the y coordinate, I want to subtract the y coordinates, and that's going to give me the diameter. So if I do 7.5 minus negative 10.5, so 7.5 minus negative 10.5, and I get 18. So that's really just finding the distance from the top to the bottom. So that is the diameter. So the radius is clearly going to be 9, which is just half of that. All right, so that's the quick way in Desmos to find the radius. I would just, again, whenever you click on a Desmos circle, they always highlight the highest and the lowest points, as well as the intercepts. But the highest and lowest points are more useful to find either the center or the radius, or the diameter for that matter, than the radius. All right, let's keep it rolling and let's head on to the next part on using sliders. So using sliders is a very, very big part of the SAT, and I really like to use them when we have a multiple choice problem. So we want to know when this has two real solutions. So what I'm going to do is put in the first one. And the reason I like this one is, and then I want to know where it has two real solutions. So when I graph this, the problem is when I do y equals k, it doesn't let me do a slider without like putting in another variable. But if you put in the variable and then get rid of it and like add the slider and then get rid of the variable, it does let you do that. All right. So now I'm just going to change, and I could have just changed this. But I just want you to see how slider works. Now I just change it to all my answers. It says exactly two real solutions. Well, one's not one of the answers. So if I go with 5, that's no solutions because the line doesn't intersect the circle. Then 4, still no solutions. 3, 1 solution. And then 2, it actually intersects the circle twice. So when k is 2, we get 2 solutions. All right, so a slider you can slide around, but I like it more for the use of just like typing in the answers, especially if there's like decimals or something like that. So just so we can see the answer one more time. So then we know our answer is 2. And like I said, I was just really wanted to show you how a slider worked. If you didn't want to do that, you could just change it here. You just make this 5, this 4, that 3, and that 2. All right, so I realize that's probably faster. But again, this is really more just like information on different things that you can do with Desmos. All right, let's take a look at another slider problem. So I'm just going to put the function in. I do not care about the f of x equals in this problem, so I'm just going to put in negative x squared minus 8x plus k, and then I am going to add a slider. And then what I want to do is if the maximum value is 25, what's the value of k? So I'm going to go up here to this top point, and I want that to be 25. So I'm going to change k to 9, which is the first answer choice. And would you look at that? We get the answer. All right. So the answer is just 9. And let's see, like the other answers are wrong. So if I put in 12, it's way above 25, and then 15 and 18, they're not, the maximum value is not 25. All right. And maximum value is by like the way it's worded, we're supposed to assume that that's the y value. All right, so just a nice quick way, again, to use a slider. Now, another way to use a slider. We want to say that the no value of x satisfies the equation. So we want there to be no solutions. So what I'm going to do here is I am going to put in the left side of the equation, because again, when you differentiate between no and infinite solutions, it's hard to do when you put it all in as one equation. So I'm going to put the left side first and add a slider, and then I'm going to put the right side. I'm going to go back to the home here. And what I want is when I put my answers in as the slider, I want there to be no solution. So I want them to never intersect. So these are lines, so they should be parallel. So if I put in 4, I can see that there is an intersection point, so there is a solution. So that's wrong. And then I look at 8, and that looks like an intersection. Then I put in 12, and there is an intersection. So then when I put in 36, I get a pair of parallel lines here, and there will never be an intersection, so therefore there's no solution when A is 36. So my answer is D. All right, let's keep going. And last one on using sliders is a system. So I'm going to put it in as is, 2x minus 5y equals 8. And then I'm going to put in the 4x plus ky equals 17. And I'm going to add the slider. And again, we want no solution, so I just run through these quickly. When I make it 10, the first answer choice, I see I have a solution. I have an intersection point. Then I make it 5. And I, again, have an intersection point. Then I make it -5, and I have an intersection point. So when I make it -10, It looks like the same line, but it's not, because when I zoom in, I see they're different and they're parallel, so there will be no solutions. So the answer must be -10. Okay, let's move on to the next part, part 7, using tables. I used a table really quick in a problem earlier, but here's more use of tables. So we got a line that passes through these 2 points. So if they give you 2 points and I want the equation of a line, I am simply going to just add a table. I'm going to put those equations in, or sorry, those points in. So 6, -3, and then 15, 0. And then you hit this little button up here, add regression. And I'm going to keep it a linear regression because this is a line, as it tells us. So this is the equation of a line. It says the line also passes through this point. What's the value of t? So if you wanted to get a little fancy here, I'm going to turn this into a function, and I'm going to say f of x equals. And I know that 0.3 repeating is 1/3, so I'm going to make that 1/3 x minus 5, and you can see it's the same line. But I really don't care about that line now. And then I just want to know what's the output when the input is -9. So I'm going to go f of -9, and it's going to just tell me that the answer is -8. So the value of t is -8. So that's how I can kind of just use Desmos like solely for every part of this problem. Okay, so and again, if you want to evaluate it at a value, that's why I had to call it a function, f of x, instead of just y, because I knew I wanted to plug in -9 to get the output. All right, let's keep going, and we are going to take a look at the next one. So now we've got tables using a quadratic. Now this one we're going to do in a similar fashion. We're going to add a table, and we've got 9, 251. But we have to realize that in order to guarantee that our quadratic is going to be a unique quadratic for the points that are chosen, we need 3 points. And those 3 points, they have to be chosen in a certain way, but just make sure you have 3 points to begin with. And it doesn't seem like they give us the third point, but they really do. They told us that c is equal to 35. We should know that the c value in standard form of a quadratic is the y-intercept. So that just means we have 0, 35. Now we should get our parabola once I change it to quadratic regression. All right, I'm going to do this one in a different way. So instead of making, and this is just, again, not better or worse, it's just before, on the last problem, what I did is I made f of x equal to that, and then I would have written like f of 7 in this case. But another option is to just graph the line x equals 7, and then we're just going to see where they intersect. So that means 7, 175, so f of 7 must be 175. All right, just showing you another way to evaluate a function. If you have the graph, just graph the vertical line and see where it intersects. All right, on to the next. So, yep, so this is our last tables problem. And okay, it's an exponential function. So this one's actually pretty easy. We only need 2 of the values. So I'm just going to do these just to save time. And then we're going to add our regression. We're going to change it to exponential. And we get that our equation is y equals 3 times 0.5 to the x. They want the value of a. They're using a as the initial value, or this coefficient, which in our case is 3. And just to show you that if I do put in this value, it's not going to change it. Right, it's still going to stay 3. So that's why I just put in 2 values. So for exponentials and linear, you just need 2. For quadratics, you really should have always have a third value if you're going to get that like unique quadratic. Okay, so that answer is just C. All right, so just how we can use exponential, quadratic, or linear kind of regression to get like use tables to find the equations that we need. All right, now on to a different type of regression. And this is our last part. So this is going to be a way to solve equivalent expressions. This is the most advanced that I get with this, with helping students. Again, like I said, there's more advanced techniques than this, but this is a pretty advanced technique that I think is really useful. So I do really like showing a lot of students this. So if we want the expressions to be equivalent, what we're going to do is I'm going to type in this first part, but I'm going to use x1. So all I have to do is type a 1 after it, and it automatically makes it a subscript. And then 36 x1 squared plus 18x1. And then I'm going to use this little like tilde, or this little like squiggly, and then I'm going to put in the other side. So 5 over k times 2x1 plus 1. All right, so now what I have is I have this expression or this equation, all right, that they're using these like regression parameters. And they're telling us what k is, but it's I believe it's wrong the way it's set up. Or no, actually maybe it's not. Here, let me kind of explain that. So we only have one parameter. So yeah, this answer is right. So it's making x1, but what I'm going to do is I'm going to say x1 equals, and I'm going to just make it 2 or 3 or 4. So you see, no matter what I make it, it's k is 6. So that is definitely the answer. K is 6 here. But I just want you to see kind of what's going on. So you count the number of constants that aren't the variable. So the unknowns that are not the variable is, in this case, just k. And our variable is x, which we called x1. And based off of that, however many constants there are that are unknown, that's how many values you need to substitute in for our variable. So the reality is, if I just make all the x1s 4, all we're going to have left to solve for is k, and Desmos is going to do that for us. So we know the answer is k equal to 6. As we're going to see in the next couple problems, it won't always be that easy. So let's do that. All right, now on to number 2 of our regression. So in this problem, again, what I'm going to do is I'm just going to put it in a kind of our regression notation. So again, these equivalent expressions, we're looking for these constants. So we have 3 unknowns here. We have x, which we're going to write as x1, and then we have, that's a variable, and then we have 2 constants that are unknowns, a and b. So since we have 2 unknown constants, we're going to have to substitute in 2 values of x to solve. So the way that looks is this way: 4 over x1 minus 1, and then plus 3 over x1 plus 2. And then the equals is the little tilde. And then I'm going to do ax1 plus b is the numerator. And then I'm going to do x1 squared plus x1 minus 2. Now what happens is it's substituting in 0 for x. But it's not giving us the correct answer because we have to plug in multiple values because we have multiple constants to solve for. If you set x1 equal to one number, then you have 2 unknowns and it's not going to give you one definitive answer. So we need 2 of them. Also notice that, so we write x1 equals, start a little bracket, and then what happens is they want x to be bigger than 1 because that would make the denominator 0. So I'm going to pick 2 and then 3, and now I got my answer. A is 7 and B is 5. Notice if I keep going, it's going to keep it there. So if I give it too many to do, it just keeps getting the right answer. It's fine to give it too much. but you don't want to give it not enough, because if I only give it 2, I don't get the right answer. But as soon as I give it a second one, no matter what 2 numbers I pick, as long as in this case we want them to be bigger than 1, or really we just don't want them to be 1, but we'll follow what they said. Then we know A is 7 and B is 5, so A times B, the answer to the actual problem, is 35. All right, so it's, again, just a nice quick way to do problems like this once you understand how to put it into Desmos. All right, let's do one more problem, I believe. Nope, we got 2 more problems. All right, so we are going to, again, just write it in as ax1 plus 5 times bx1 minus 5 tilde cx1 squared plus 15x1 minus 25. Now I have 3 unknown constants, so I'm going to put in 3 values. So I'm going to do x1 equals bracket and then maybe 1, 2, 3. And let's look what happens when I do 4. It keeps giving me the same answers. So I know that A is -2, C is -2, and B is 1. So the value of B minus A is 1 minus -2, which is 3. Okay. And if you're really concerned with how many values, just start putting them in until they all snap to the same answer, right? You see, you just keep, once you start getting the same answer over and over again, you should be good to go. And all right, let's move on to our last problem. So here we have 4 constants. So let's do 2 over x1 squared plus 4 plus 5 over x1 minus 2 tilde. Now our numerator is a x1 cubed plus b x1 squared plus c x1 plus d all over x1 to the 4th minus 16. And I have 4 of them, so I'm going to put in 4 numbers. But I don't want any denominators to be 2, so I'm going to be 0. So I'm going to skip over 2. So I'm going to do x1 equals, I'm just going to start at 3. I'm going to go 3, 4, 5, 6. And see if I keep going. If I get rid of that, you see I get 5, 12, 20, 32. And then if I put in 7, I still get 5, 12, 20, 32. So that makes me confident that that's the values. And it wants me to just add those together. So that's 17, 37, and 69. I could just double check that. 5 plus 12 plus 20 plus 32. Yeah, 69. Okay. All right. Then that is it. So thank you for watching this. I hope it was helpful. Let me know if there's any other tips or anything to do with Desmos that you know about. If you want to see even more advanced, I could get that together. I'm also going to be doing something where I compare whether, we should, or whether it's best to use Desmos or do it by hand. That's kind of the next level to this. But in the beginning, it's really just mastering, being able to do everything that's in this video. Just knowing how to do that is kind of step 1. All right? Again, hope that helped.